Intermediate Algebra 4 Statistics, Graphing Square Root Functions, Part 2. Lesson Objective: explain the graphical significance of a, h, and k for the function y equals a times the square root of x minus h plus k. In the previous video, we looked at changing the value of a, where a was larger than 1 and a was in between 0 and 1. So what happens if a is negative? If you recall, our parent function is the square root of x. So if a is negative 1, what does the graph of a times the square root of x look like? We hit graph. Here's our parent function, and here is the new function. So we see that if a is negative, it's really a reflection across the x-axis. If we look at the table of values, we can see the values between y1 and y2 are the same numbers except opposite signs. When this happens, that's a reflection across the x-axis. So here's our parent function. If a is a negative 1, it is a reflection across the x-axis. If the negative is inside the radical, which we're not going to look at in this course, it's a reflection across the y-axis. But for this class, we're only concerned when a is a negative number. This is an increasing function, and when a is negative, this is a decreasing function. As x gets larger, y decreases. So here's our parent function, square root of x. When a is 1/2, it's still an increasing function, but it's not as fast as when a is 1. When a is 2, it's an increasing function, and it's at a faster rate than when a is equal to 1. These three graphs, a's are negative, so they're all decreasing functions. And the larger the negative a value, the faster the function is decreasing. Let's summarize the family of these square root functions. In this form, f of x equals a times the quantity square root of x minus h plus k. A is a vertical stretch, or it could be a compression by a factor of absolute value of a. If a is larger than 1, it's a vertical stretch. If a is in between 0 and 1, it's a compression. If a is negative, then it's a reflection across the x-axis. The value of h affects the horizontal translation. Now, if you recall, translation is a fancy way of saying sliding. So if h is positive, it translates to the right h units. If h is negative, it translates to the left. And if h is negative, then this will become x plus h. K is a vertical translation. It's going to go up or it's going to go down. If k is positive, you translate it up k units, and if k is negative, you translate it down the absolute value of k units. So if k is positive, you go up, k is negative, you go down. If h is negative, which will make this a plus, you go to the left. If k is positive, you go to the right. And a will tell us if it's an increasing or decreasing function. If a is positive, it's an increasing function. If a is negative, it's a decreasing function. So here we have 5 graphs. Here's our parent function. If we look at the red graph, h is 3, k is 0, and a is 1. So comparing the red graph with the parent graph, it's the same graph except for it has been translated 3 units to the right. because h is 3. If we look at the light blue graph, it's the same graph as the parent function, except it's been moved 2 units to the left. H is a -2. K is still 0, A is still 1. If we look at the pink graph, K is 5, so it's a translation up 5 units. And if we look at the green graph, K is a -3, so the parent function has been shifted down 3 units. Properties. If we have g of x equals the square root of x minus 2, that means h is positive 2, which means we move the parent function 2 units to the right. If we have the square root of x plus 2, h is -2, we move it 2 places to the left. If we have g of x equals the square root minus 2, we go down 2 units. And if g of x is square root of x plus 2, we translate the parent function up 2 units. If a is positive, it's an increasing function. If a is negative, it's a decreasing function. Here we have a graph where h and k are positive. H tells us how much to move it to the right, and k tells us how much to move it up. And since this is an increasing function, this value of hk is a minimum. For this graph, this is a decreasing function, so that means a is negative, and this hk is a maximum value. Let's do some examples. Example 2. Sketch the graph of f of x equals 4 times the square root of the quantity x plus 2, and then we minus 5. Is f of x an increasing or decreasing function? Is there a maximum or a minimum? Well, because a is 4 and it's a positive number, this is an increasing function. And because it's increasing, it will have a minimum value. The minimum point would be h, k, which would be -2, -5. So if we graph this using our graphing calculator, we see it's an increasing function. Right here is the point hk, and we can use our table and see our hk point is -2, -5. Anything to the left of -2 is undefined. The smallest value of y is -5. Example 3. Sketch the graph of g of x equals -3 times the square root of the quantity x minus 6, and then we add 2. Is g of x an increasing or decreasing function? Is there a maximum or a minimum? In this case, a is a -3, therefore it's a decreasing function, which means there will be a maximum value for the y. H is a positive 6, k is a positive 2. Solution: putting the equation in y1, graphing it, we see that this is a decreasing function, and it looks like the maximum point is here. This is hard to see, so we will use our table, but we know this is occurring at 6, +2. So any values to the left of 6 are going to be undefined, and the largest y value is a +2. Using our table, we see anything less than 6 is giving us an error, it's undefined. And then the largest y value is the value of k, which is 2. Properties. If a is a large number, then the graph of g of x equals a times the square root of x minus h plus k rises more quickly than the graph of the parent function, square root of x. If a is a positive number near 0, then the graph rises more slowly than the parent function, square root of x. If a is a negative number, then it's a reflection across the x-axis. The value of k is either a minimum or a maximum value for the function. If the function is increasing, where a is greater than 0, then k is a minimum. If the function is decreasing, it means a is negative, then the value of k is a maximum. To sketch the graph of f of x equals a times the square root of x minus h plus k, where a is not equal to 0, number 1, we sketch the graph of y equals a times the square root of x. Number 2, we translate the graph in step 1 to the right h units if h is positive, and to the left absolute value of h units if h is negative. Number 3, we translate the graph sketched in step 2 up by k units if k is positive, and down by the absolute value of k units if k is negative. Thanks for watching.